Welcome to mathematics. My name is Sir Mangeya, the Maths Eagle. Right, so my contact or my digits, they are appearing on the screen. I'm sure I can see them, and my name is there. So this one is the A-level, advanced level mathematics, Cambridge, paper 3. Actually, it's for 2017 specimen paper for 2017. I work out this question paper from question number 1. So please, maths is actually nice, it's actually easy. Just follow me up as I'll be working out this one for you, right? So then after watching, please don't forget to like the video, subscribe. That's only the thing that you're supposed to do. Share also with others, right? This nice content actually from the Eagle himself, Sir Mangeya. So share with others, let them also watch out and also share and share and share. Right, now let's start. As you can see on the screen, pure mathematics paper 3. The first part, I also worked out the paper 1 for this one. So if you haven't gotten a chance to watch out the paper 1, so please just find it on my YouTube channel, Sir Mangeya. You also find the paper 1 of this same 2017 specimen paper, right? Pure mathematics. Right, question number 1. It reads: solve the inequality 2x minus 5. So those ones are called the magnitudes or the modulus of those values that are inside the modulus, right? Or the modulus function. So what you do for you to be able to solve this one, you square both sides, or you square all the values both on the left side and on the right side. So you square everything. Let's square. This one will be 2x minus 5. Then you square this one, greater than. You also square the 3. You also square this one, 2x plus 1. Now simplify. The usual way or the normal way that you know how we remove brackets is at form 4 star. This form 4 star, or even form 3 actually. Let me just say form 2 star. Because the way you remove brackets, please don't do more of shortcuts. Otherwise, you end up applying the wrong way of removing brackets. So this is how you remove brackets, right? So expand. Long expansion. 3 squared is 9. Then this one, you also do the same. 3x plus 1. Then 2x plus 1. Same brackets with same values. Right. Then expanding this one, you say 2x times 2x. What do you get? The numbers or the values in the first bracket will multiply the values in the second bracket, right? That's how you work out, you remove brackets. So in the first bracket, 2x and minus 5 will multiply the values in the second bracket. So 2x times 2x, you get 4x squared. Then 2x times minus 5, you get minus 10x. Then you also move on to minus 5. Minus 5 times 2x is minus 10x. Then minus 5 times minus 5 plus 25 greater than. Right, here first you maintain the 9 and you simplify this bracket. So 2x multiplying 3x plus 1. Then plus 1. 3x plus 1. In fact, let me just remove this bracket once and for all. Alright, so on this one, let me just multiply directly. So we say the numbers in the first bracket, they will multiply the numbers in the second bracket, right? So 2x times 3x, you get what? 4x squared. Then 3x times 1 is plus 2x. So let's simplify this way so that your working space will be limited, right? So you don't just have to write everything. Otherwise, you end up getting short of your working space. 1 times 2x then to be plus 2x, then plus 1, like this. Let's simplify further. It will be 4x squared minus 20x plus 25 is greater than, here it's 9, then in brackets 4x squared plus 4x plus 1, like this. Right, next, let's remove the brackets on the right side. So it will be 4x squared minus 20x. You maintain this side. Let's maintain this side before you can collect like term. Then this one, 36x squared plus 36 plus 9. Right, now let's collect like terms. And in this case, it's better for you to put your values on the right side. Why? For the coefficient of x squared to be positive. It's easier that way. So let's leave 0 on this side. Then 36x squared. Let me just subtract here. Let me just subtract 36x squared minus 4x squared. Well, this 4x squared will be negative on this side, so it will subtract. So it will be 32x squared. Then this one, 36x minus, it will be plus 20x. 36x plus 20x, it will be plus 50x. Right? Then this one, 9 minus 25, it will be minus 16. Like this. Then you can search, is there a common factor between these values, right? Is there a common factor between these values? So this one will be minus 56. Actually, it's minus 56. This one is 56. Or first, let's put them on this right side so that you can be able to work easily. Plus 56x minus 16 is less than 0. Right, so please take note, 0 greater than 36x squared plus 56x minus 16 is the same as, you can start by writing this value, then you say less than 0. Take note of the inequality, the side that is facing, right? So it's still less than, the interpretation is 1. Now, on this one, do we have a common factor here? 16. Can 16 get into 56? No, it can't. But what can be the common factor, right? You can see there's 8 here. So it divided by 8, each item by 8, you get 4x squared plus this one will be 7x, then minus 2 less than 0. Then after this, let's factorize this number on the left side. 4x squared plus 7x minus 2. Let's find two numbers. When you multiply them, they must give you this number times this number, which is 4x squared times minus 2, which is minus 8x squared when you multiply them. So they are the factors of minus 8. And when you add or subtract them, they must give you the number that is at the middle, which is plus 7x in this case. Which are the numbers? As you can see, we have plus 8x minus x, plus 8x minus x. So it will be 4x squared plus 8x minus x minus 2 is less than 0. Then let's factor out 2. You factor out 4 here. 4x, then it will be x plus 2, then minus 1 here. You get x plus 2 in the brackets less than 0. As you can see, x plus 2, they are the same. So you start by writing those values that are the same. X plus 2, then the numbers outside the brackets is 4x minus 1. You also put them in their own bracket. What makes the inequalities different from the equal sign is this. When you are working out inequalities at A level, you are supposed to find the critical values of x, right? You find the critical values of x. Then let's find the critical values of x. You say x plus 2 is equals to 0. Then from this one, you can get x is equals to minus 2. If you can simplify this one. Then on the second one, it will be 4x minus 1 is equals to 0. Then if you can simplify this one, you get x is equals to 1/4. That's what you get. Right, since it's a quadratic inequality, you can just, there are two ways. You said I can just draw a simplified graph, a sketch, or you can use a table. But on this one, let's just use a graph. It's like this one. Just draw your x-axis, then you draw your quadratic graph. This one, the coefficient of x squared is positive, so it will be like this. Right, then the lowest value is -2, the highest value is to be a quarter, or the highest critical value is a quarter. Then you now consider this sign here. If it's less than, what we need is the area that is below the x-axis. If it's greater than, then we want the values that are above the x-axis. But in this case, it's less than, so it means we want the area or the region that is below the x-axis, which is this region. Let me shade the region that you want. Is this region. This is the region that you want. So the solutions, they lie from this part to this part, which means from -2 to a quarter. That will be the solution. So solution, x lies between -2 and 1/4. This is the solution. We are done. Let's move on to the next question. Question number 2. Substitution. Right. It reads, using the substitution u is equals to 3 to the power x, solve the equation 3 to the power x plus 3 to the power 3x is equal to 3 to the power 3x. Giving your answer correct to 3 significant figures. These are 5 marks. So when you are using substitution, please, you have to apply or to remember the concept of indices. You apply indices on this one. So first, you express in this form. You say 3 to the power x plus 3 to the power x. This one is the same as 3 to the power x squared is equals to 3 to the power x, then to the power 3 is the same as like this. Then with this 3 to the power x, then you can put u. It will be u plus u squared is equals to u to the power 3. Right. So for you to be able to easily work out this one, it's better you can put the values on the right side. You say u cubed minus u squared minus u is equals to 0. There's a common factor u in this case. You can divide everything or each item, each value by u, and you get u squared minus u minus 1 is equals to 0. Now, this one is a quadratic equation in u. You solve it as a quadratic equation. Can you see there are no factors on this one? So, given that there are no factors, you are supposed to use, it's either completing the square method or you can use the quadratic formula. In this case, let's use the quadratic formula, and our a will be 1, our b is equals to -1 based on our quadratic formula, please remember, and our c is equals to minus, c is also equals to -1, because it's in the form of it's ax squared plus bx plus c is equals to 0. This one is the quadratic equation. So our a coefficient, the one with the square, then the one with an x is later without a square, it's a b, then the constant is our c. Let's substitute. So u is equals to minus b, which means -1, plus or minus the square root of b squared, which is -1 squared, minus 4ac, a is 1, then c is -1, all over 2a, which means 2 times 1, since our a is 1. Right, let's simplify further this one. Minus 1, it will be what? Plus 1. Plus or minus square root of 1 squared is 1. Then minus, it will be a plus. Then 4 times 1 times 1, it will be 4. Over 2 times 1 is 2. So you get u is equals to 1 plus or minus √5 over 2. You separate the two. You say u is equals to 1 minus √5 over 2, or u is equals to 1 plus √5 over 2. Now, you have to use your calculator, right? You have to use your calculator. Your calculator, if you can say 1 minus √5 over 2, what do you get? 1 minus √5 over 2, what do you get? You can use your calculator. 1 minus √5, then your answer you divide by 2. You get minus 0.618, or u is equals to, then on this one, if you can simplify, here, just punch in your calculator, plus, then what you get is 1.618, like this. Now, based on our substitution, what did we say? We said let u is equals to 3 to the power x. Up here, u is equal to 3 to the power x. What you want are the values of x, not the value of u. So you have to substitute again further. Because 3 to the power x, say 3 to the power x is equals to the first one, minus 0.618, or 3 to the power x is equals to 1.618, like this. Then introduce ln, but on this one, the first one, if you can say ln 3 to the power x is equals to ln minus 0.618. Ln of a negative number, that one you find in error in your calculator. So this one you can do away with this one. You can just leave it like that. Then you consider the second solution is the one that can give us a solution. Ln 3 to the power x is equals to ln, you introduce ln 1.618, like this. So it will be x ln, apply the laws of logarithms. X ln 3 is equals to ln 1.618. Then you divide by ln 3 both sides, you get x is equals to ln 1.618 over ln 3. Then if you can punch in your calculator, what do you get? Just punch in your calculator, ln 1.618, then divided by ln 3. So you get 0.438. Correct to 3 significant figures. 1, 2, 3. So correct to 3 significant figures. This will be your x value. We are done with this one. Let's move on to the next question. Question number 3. It reads, the angles theta and that one lie between 0 and that one 180 degrees, and are such that their tan of the difference between the two angles is equals to 3, and their sum, tan of their sum, is equals to 1. Find the possible values of them. So we want to find these angles, right? So we can start by finding this theta. How can you find the angles? We use, or we apply identities. These are like simultaneous equations, so you have to solve them simultaneously. If you can say tan theta minus the tan theta minus this one angle is equals to 3. Use the expansion of tan theta, tan 2 theta, based on those double angles. So what will be the expansion? So you say tan is equals to tan theta minus tan, let me call this one alpha, over tan 1 plus tan theta tan alpha is equals to 3, like this. So that's what you do. Then we also given this value here, with tan theta plus tan alpha is equals to 1. So now, how can we work out this one? What you do is, you have to substitute, right? You have to substitute. Like on this one, let's make tan theta, or this one, tan of this one, you say tan alpha is equals to 1 minus tan theta. If you can use this one, make tan theta subject to tan or alpha subject of formula here. In this case, what we get? 1 minus tan theta. Then replace, substitute. So you say tan theta is equals tan theta minus, where there is tan alpha, you put 1 minus tan theta. over 1 plus tan theta times 1 minus tan theta is equal to 3. Right, then you come here, you simplify or you remove the brackets. Tan theta minus 1 plus minus 1 plus tan theta over 1 plus tan theta minus tan squared theta is equals to 3. Like this. Right, let's simplify further. Tan theta plus tan theta is 2 tan theta here. 2 tan theta minus 1 over 1 plus tan theta tan minus tan squared theta is equals to 3. Now cross multiply. It means all these values down here, they have to multiply 3. It will be 2 tan theta minus 1 is equals to, multiply everything by 3 here. It will be 3 plus 3 tan theta minus 3 tan squared theta. Like this. Now we have to collect like terms. Or if for the value of tan squared theta to be positive, it's better we can transfer all our values to the left side, so that it will be 3 tan squared theta plus 2 tan theta minus 3 tan theta, then minus 1 minus 3 is equals to 0. Then simplify this one further. 3 tan squared theta, then this one plus 2 tan theta minus 3 tan theta is minus tan theta minus 4 is equals to 0, because minus 1 minus 3 is actually minus 4. Next, it's now a quadratic equation. What you can do, if you can find it difficult to work out with tan theta, what you can do is you can let x is equals tan theta. Let's do it that way. Let x is equals to tan theta, which means 3x squared, we have to change our equation, minus x minus 4 is equals to 0, like this. Then let's simplify further, or just have to factorize this one. Yeah, let's factorize this one. Right, 3x squared minus times minus 4, we get minus 12x squared. So which numbers are the factors of minus 12? When we subtract or add them, they give us 1. They are actually, it's minus 4x plus 3. So we say 3x squared plus 3x minus 4x. These are the values. Minus 4 is equals to 0. Now let's factorize. It will be 3x here. Factor out 3x. You get x plus 1. Here factor out minus 4. You get x plus 1 is equals to 0. Then x plus 1, you write x plus 1 in brackets. Then the other one, you also write the numbers outside the brackets. 3x minus 4 in their own brackets. Alright, we're done. It's either x plus 1 is equal to 0 or 3x minus 4 is equal to 0. So it's either here x is equals to minus 1, or if you simplify this one, you get x is equals to 4 over 3. Alright, that will be final answer. Since we said this one is equivalent to tan theta, so we say tan theta is equals to minus 1, or tan theta is equals to 4 over 3. Now, we have to find the principal values, or the primary values. On this one, you get theta is equals to, you say arctan of minus 1. This one is minus 1. On this one, it will be arctan. Theta is equals to arctan of 4 over 3. If you can simplify this one, you get theta is equals to arctan of minus 1. What is arctan of minus 1? You can use your calculator. arctan of -1, you get 45. Or for us to be able to work out, let's use in this case the quadrant rule. So you just have to remove the minus here, right? So don't worry about the minus, just put theta is equals 45. Then the minus work when using the quadrant rule, right? Then on this one, theta is equals to arctan of 4 over 3. Arctan of 4 over 3. What do you get? 4 divided by 3, you get 53.1. 53.1 degrees. So this is your theta based on this one, and this is your theta based on this one. Now let's use the quadrant rule. We can use the first solution. Theta is equals 45 degrees. Then you can find the values of theta. You also use theta is equals 53.1 degrees. You can find the values of theta. In this case, the values of theta must lie between what? They must lie between 0 and 180 degrees. You can see that they on the screen. So it's 0 and 180 degrees. These are the values that we want. So on this one, first one, you draw your quadrant like this. Then on this one also you can draw your quadrant. Now on this first one, you can see that tan theta is negative here. Tan theta is negative here, which is tan theta is equals to -1. So in which quadrants is tan theta negative? In which quadrants is tan theta negative? So that one you can even prove using your calculator, right? Usually first quadrant, all the values they are positive. Then tan theta, when it comes to the second quadrant, tan theta is negative. Then the third quadrant, tan theta is positive. The fourth quadrant, tan theta is also negative, right? So tan theta is positive in the first and the second, and tan theta is negative in the first and the third, and tan theta is negative in the second and the fourth quadrant. So in this case, tan theta is negative. So it means we need to find our angle in the second and fourth quadrant. So it's like this. So this is negative. So this is our PV, 45 degrees. Yeah. Then the other one, fourth quadrant. But remember, this one the first quadrant, this one the second, this one the third, this one the fourth quadrant. Like this. And on this one, let me just put all the angles so that I can work them out. On this one, tan theta is positive. So tan theta is positive in the first and the third quadrant, which means 53.1 is supposed to be in the first quadrant, which is this one is 53.1, and in the third quadrant is where you can find 53.1, like this. Let's check out the first one, the first quadrant. Our solution that we need is the angle that will be made with the positive x-axis, right? So on this one first, our angle is this one. This is our first solution. What is the value of this solution? We say theta is equals to, this one is 180 minus 45. 180 minus 45. Or let me just write the answer. What is 180 minus 85? The 1 minus the 45. 180 minus 45. What's the answer there? 180 minus 45. What do you get? 135. So this one is 135 degrees. It's in the range. But so this one is only one solution, 135 degrees. On the second one, let's find theta is in the second solution. This one. The first solution here in this case is the angle from the x-axis, the first line. This one will be 53.1 degrees. Then the second angle, it will be from this line to the second line. For it, this one is 180 plus 53.1, for which it will be above our range. Our range ends up to 180. It ends at 180. Even on this first one, the next angle up to this line, for which this one is out of range, because it will be 360 minus 45. is out of range. Our range is from 0 to 180 degrees. So the values of theta are 135 and 53.1. Now, we want to find the corresponding values of the other angle alpha. You can call it alpha. This one, we said tan theta, tan alpha is equals to 1 minus tan theta. 1 minus tan theta, you can use that one. Let's use that one. We said tan alpha is equals to 1 minus tan theta. So for the first one, we use 1 minus tan 135. Let's use theta is equals to 135. Then what do we get? What do we get here? You get tan alpha is equals to 1 minus tan 135. 1 minus tan 135. What will be the answer? 1 minus tan 135. You get 2. Then your alpha is equals arctan of 2. Arctan of 2. Then it will be arctan of 2. What will be the answer? Arctan of 2 is 63.4 degrees to 3 significant figures. Then let's also work out using this one. Alpha is equals to 1 minus tan 53.1. It will be alpha is 1 minus tan 53.1. What's the answer? 1 minus tan 53.1. You get minus 0.331 or 332. Then this one will be arctan of this same answer, minus 0.332. Arctan of this answer, what do we get? Arctan of, using a calculator, minus 0.332. It's 18. This one you get minus 18.3, meaning that it's below the x-axis. Right, so we are done. We're done with this one. Let's move on to the next part. Next question, question number 4. This one was question number 3. Question number 4. Right, so this one is on the rules. These are rules, the iterative formula. It reads the equation x cubed minus x squared minus 6 is equals to 0. Here is one real root denoted by alpha. First part, find by calculation the pair of consecutive integers between which alpha lies. Between which alpha lies. What you do is this one you do is try and error method. Use try and error method. So if there is a root between two values, there must be a sign change. But first, before you can do all those things, you say let f of x is equals to x cubed minus x squared minus 6. Then you try and error. You can put f of 1, f of 2, f of 3. Let's put f of 1. Let's put f of 1. If you can put f of 1 here, it means where there is x, we are supposed to put 1. It will be 1 cubed minus 1 squared. It will be 1 minus 1. So it will be 0. Then minus 6, it will be minus 6, right? If you can put f of minus 1, it will be minus 6. Then f of 1. Then let's put f of 2. 1 to see if there's a sign change. Then you can conclude that the pair of values is 1 and 2. But if there's no sign change, then you move on to the next integer, which is 3. Let's put f of 2. If you can put 2 here, 2 here, 2 cubed is 8, minus 2 squared is 4, 8 minus 4, what do you get? 4, then 4 minus 6, it's minus 2, so there's no sign change, which means let's do away with this one. So let's start at 2. So at 2, what did you get? And let's use 2 and let's try 3. So we got minus 2 when f of 2. Let's now put 3. If you can put f of 3 there, Then put 3 where there is x. What do you get? 3 cubed is 27 minus 9 minus 6. 27 minus 9 minus 6, it will be 12. So there will be a sign change here between 2 and 3. So you put first f of 2. You say f of 2 is equals to 2 cubed minus 2. Let me put 2 here, not x. Minus 2 squared minus 2 squared, then minus 6, which is equals to minus 2. If you can simplify this one further, then let's put f of 3. This is what you do, is equals to 3 cubed minus 3 squared minus 6, which is equals to 12. So there's a sign change. So the two values are 2 and 3. So it's 2 and 3. See, there's a sign change between 2 and 3. Because this one is 12, this one is minus 2. It's now plus 12, that one was minus 2. Therefore, we conclude that a root lies between 2 and 3. Right, next question. Show that if a sequence of values given by the iterative formula xn plus 1 is equals to, that one is given, you can see on your screen, converges, then it converges to alpha. What is the equation which have the root alpha? It's here on top here. X cubed minus x squared minus 6 is equals to 0. Let me write it down. X cubed minus x squared minus 6 equals 0. So you have to prove that this equation can lead to this one. That's what you have to prove. For you to be able to prove that it converges to the root alpha, we satisfy this same equation. You take this equation, you say, you remove n plus 1, you remove n, you just ignore those things, right? Just ignore those things. So it will be xn plus 6. Let me remove this funny xn. You just put a x, right? You don't put an n like this. You have to remove this n. Just have to put a x. Then, if you can simplify this one, you square both sides. To remove the square root, you square both sides. It will be x squared is equals to x plus 6 over x. Then multiply everything by x. Multiply everything by x, you get x cubed on this side is equals to x squared plus 6. Then expressed in this form. Just expressed in this form. So it will be x cubed minus x squared minus 6 is equals 0. Then you have shown. We are done. That's how you work it out. Alright, next part. Use this iterative formula to determine alpha, correct to 3 decimal places, give the answer of each iteration to 5 decimal places. Right, so since we found out that a root lies between 2 and 3, it means the first value that we use is our x0 is 2 plus 3 over 2, which is equals to 2.5. So use x0 is 2.5. Right, so now if x0 is 2.5, what is x1? So x1 is equals to, let me check our formula that we're using. Is this one? Xn plus 1 is equals to square root of xn plus 6 over xn. So it's square root of xn, in this case, which is 2.5 plus 6 over 2.5. Right, and give your answer to 5 decimal places. And your root you want it to 3 decimal places, but give the result of each iteration to 5 decimal places. To 5 decimal places. So how are you supposed to work this one out? Right, so what you do is you do it like this. You punch this one in your calculator. Let's punch this one in your calculator. What will you get if you can punch this one in your calculator? Square root of 2.5 plus 6 over 2.5. Then what do you get? You get 2.213 to 5 decimal places. 1, 2, 3, 4, then 9. 5 decimal places. Then now let's move on to x2. x2 is equal to square root of. Now we are putting 2.21359. Wherever there is x, you have to put this value. We are now putting x1 plus 6 over 2.21359. Then you punch in your calculator. What do you get? Then for it to be easier for you in your calculator, what you're supposed to do is simple. What you do is you just replace where there's x, you replace with answer, right? So there's an answer function on your calculator is there. You can punch answer there. Then on this one you can also put answer here, right? Then you can find your answer, right? So that's what you're supposed to do. You find your answer, right? So what do you get? What do you get if you can simplify this one? Square root of, so it's square root of 2.21359 plus 6 over 2.21359. You get 2.219 0 to 5 decimal places, so it will be 04, like this. Let's move on. x3 is equals to, then you write square root of the answer that you have just gotten, 2.21904 plus 6 over 2.21904. You put this one. Then if you can punch in your calculator, what do we get? If you can punch in your calculator, what you will get, what will be the answer there? Punching in your calculator. So let me punch in my calculator. 2.21904. 2.21904. Then you get 2.21876. Right, let's check. Maybe we found our root. It's supposed to be to 3 decimal places. If you can come here, then round off to 3 decimal places, you get 9 here. 2.219. So that's supposed to be our root. Even above here, you get 2.219. So it means our root is supposed to be 2.219. That is to 3 decimal places. To 3 decimal places. Is to 3 decimal places. So 1 to 3 decimal places. Then we are done with this part. Right, let's move on to the next part. The equation of a curve is y is equals to e to the power minus 2x tan x for x lies between 0 and 1 over 2 pi. Obtain an expression for dy dx, that's the first derivative, and show that it can be written in the form where a and b are constants. Where a and b are constants. Right. So let's show that we can be able to write in that form. How can we show that we can be able to write in that form? Right. So what you do is, this one is product differentiation integrating uv. So you say, right away, let's say, let u is equals to e to the power minus 2x, and v is equals to tan x. Then du over dx is equals to minus 2 e to the power minus 2x, and dv over dx is equals to, it's sec squared x. Differentiating tan x, you get sec squared x, like this. Then dy dx is equals to, it's u dv dx. U dv dx, which means our u, let me, u dv over dx plus v du over dx. So which one is our u? Let's substitute. Our u is e to the power minus 2x times, then dv dx is sec squared x. Sec squared x plus v is tan x times du dx. Which one is du dx? It's minus 2 e to the power minus 2x, like this. So this one will be e to the power minus 2x sec squared x minus 2 e to the power minus 2x, then tan x. Right, let's factor out e to the power minus 2x. If you can factor out this one, you will remain or be left with sec squared x minus 2 tan x, like this in the brackets. Then let's use this identity. Tan squared x plus 1 is equals to sec squared x. So that we can replace sec squared x with tan squared x minus 1. So it will be e to the power minus 2x, then tan squared x plus 1 minus 2 tan x. Right, let's express the value inside the bracket as a quadratic equation. It will be tan squared x minus 2 tan x plus 1, like this. Now, let's solve this one. Let's solve this one inside the brackets. We say, or factorize this one. Let tan x, or let y equals tan x. For it to be easy to work with, let y equals tan x. So let's take this one. So it will be y squared minus 2y plus 1. Let's factorize this one. What do you get if you can still factorize this one? You get, what are the factors? Factors is minus 1 minus 1. So it's y squared minus y plus 1. Which is equals to y, which is equals to y. Then by factor out, you get y minus 1. Then minus 1, you get y minus 1. If you can factor out this one, you say y minus 1 is the same as y minus 1 squared. This is the same as y minus 1 squared. Like this, right? The same as y minus 1 squared. For which you said, let y is equals tan x. Then we replace. So it will be equal to e to the power 2x. Then we replace. Where there is y, we put tan x. So it will be tan x minus 1 squared, like this. But our expression, it wants us to leave it in this form. So it's e to the power minus 2x, then minus 1 plus tan x, then squared. Then we are done. So this is what you are supposed to do. This is what you are supposed